Assalamu alaikum students, this is Farwa Batul, your O-level computer science instructor, and welcome to another video of chapter number 10. We are done with example 1, 2, 3, 4, 5. And in this video, we will be doing example number 6 of chapter 10, Boolean Logic. Okay, so the example says that it's a practical example. There is a safety system. Look over here. A safety system uses three inputs to a logic circuit. It's very important. We have three inputs. An alarm X sounds if input A represents on and input B represents off. There is a OR. If input B represents on and input C represents off. So this is a particular condition in which your safety system is going to produce a sound. Now, what you have to do, you have to produce a logic circuit for this and a truth table to show the conditions that cause the output X to be 1. Okay, so let's start with the working. Let me clear to you that there are three inputs and the inputs are like, they are named as A, B, C. And there is output, or we can say output is X. When the value of X is 1, it means that the sound will produce. And when the output is 0, it means there will be no sound. Now, what you have to do first, you have to make the logic expression out of the condition that is given to you. So let me quickly do the working for logic expression. For logic expression, what you have to do, you have to check out the conditions that are given to you. An alarm X sounds if, you have to see over here. It means the conditions will be X equals to 1. The output will be 1 if, let me write it here, there are two things. When input A represents on and it continues with and. Input B represents off. This is the first condition when your output will be 1, which says that the condition says that input A represents on and input B represents off. Okay. The second thing is, let me just write it a little down so that it will be easier for me when I will be writing the logic expression. Okay, then there is OR. OR means that there is another condition that makes your output 1. The second condition is when input B represents on. So right over here, input B represents on and along with that input C represents off. Off. Okay, let me clear one thing before writing down the expressions for each of these conditions. On means 1. And if it is 1, we write it as input A. And off means 0. And if it is 0, we write it not A. If the value of A is on, the input is on, then we will write simply A. And if the input is off, we will write it as not A. So look over here. The first thing, input A represents on. It means we will write A as it is. Then there is AND. It means that you will be connecting input A with an AND logic gate. Then the second part says input B represents off. It means we will be writing, since B has of value, so it will be written as not B. Because if your input has a 0 or an off, then we write with a not. We make it invert. It will come with an inverter or with a NOT gate, not B. Now, same goes with the second one. Input B represents on. Value of B is on. On means 1. And if B is 1, then B will be written as it is. There is AND between the condition. Input C represents off. Off means 0. If the value of input is 0, we will make it not C. This I wanted to explain you, that if the value of input is 0, write it with a not. And if the value of input is 1, write it as it is, like A, B, or C. Okay, so if you have understood this now, let me quickly show you that the important thing in the question is these two conditions are connected with or. Either this is going to work, this will give you the output 1, or either the second condition. If it is true, then the second condition will give you an output 1. So both the conditions are connected with or. So what you can do, simply write down the final version. In the final version, you will be connecting both of these expressions or conditions with a OR gate. So how we can do that? We can just make a bracket over here, write down A and not B, which is condition number 1, connect with the OR gate, then make it B and not C. Okay, so if I write the same thing in Boolean algebra or Boolean logic, so what it will be, A will be written as it is, and operator will become a multiplication sign or a dot, then not B will be written like this, B bar, then this OR will become addition, plus sign, then B will be written as it is, and will be a dot or multiplication. Not C will be written like C bar. So this is how we write the expression in Boolean, or we call it a Boolean expression. Okay, once we are done with the logic expression, now quickly moving towards the truth table. There are two ways of producing a truth table in Boolean logic. A truth table can be produced from logic circuit, table, and a truth table can also be produced from logic expression. These are the two ways. Okay, if I follow the first one, then I must have the logic circuit for it. And if I see the example, in the example, it's written that you have to produce a logic circuit from the logic expression first. So once we are done with the logic expression, we will be making, look over here. This is your logic expression. So first what you have to do, you have to make a logic circuit from your logic expression. This is, let's suppose, part A of your example number 6. So let me quickly do it for you. Okay, so here is my logic expression. Now let's solve the brackets first. The first bracket says that you have A and you have not B. It means that the input B will go through a NOT gate so that it will become not B or B bar. And then both will be going through a AND gate. And this is the intermediate output. Okay, the second part says that B will go directly into the AND gate and there will be another input that is not C. Not C means that C will be going through an inverter. so that it will become not C. And finally, both of these inputs will go through an AND gate. So this is your condition number 1 and this is your condition number 2. So both of these conditions are going to be connected through an OR gate. So let's just make the final version of your logic circuit. So in the final version, what you will be doing, this is your input A, this is your input B, and this is your input C. No need to make two lines for each of these inputs. Make only one line and work like this. Input A and input B through an inverter to an AND gate. This is condition number 1. Input B will go directly to the second AND gate and C will go through an inverter. If you see the second condition, B is going directly and C is through the inverter, and this is how you connect both the circuits. And finally, both of these will be joined using an OR gate. So this is a one AND gate, this is another AND gate, and this is your OR gate joining the two conditions. And here you will be having intermediate values, and this inverter is going to make B bar, this inverter going to make C bar, and this is how the circuit, the logic circuit will be for this particular example. So once you are done with the logic circuit, now quickly move towards the truth table. Okay, so I have already informed you that a truth table can be produced by two ways. Number one, from logic circuit, and number two, from logic expression. We have already covered both of these ways of doing the truth table in the previous examples. In this example, I will be following step number 2, this one, because this is going to help us to see that whether our logic circuit is correct or not. So we will be, this method is going to be more useful according to your book. It says that this method will confirm us that our logic circuit that we produced is correct. So let me quickly show you the truth table and then we will start working on it. Okay, so here we go. This is the truth table that I have pasted from your book, and I have removed all the values. So I will be doing the walking, and it will be easier for us to understand that how we can fill the truth table. So remember that if you have 3 inputs, you will be having 8 input combinations. And I have already discussed that how we can make these distinct combinations, different ones. You can watch the previous videos, you will come to know about this. Okay, next, I am using the method of making truth table out of the logic expression. You can also make the truth table out of the logic circuit. It's up to you how you want to work. So what I am doing, I will be calculating the intermediate values. This is my condition number 1 that says that A and not B is the first condition when the output will be 1, and this is your another condition that you need to calculate B and not C that makes your output 1. So we will see that if the values of A, B, C have different values, then how this is going to work for this particular circuit. So let's see that calculating each of these conditions and then looking at the results. Okay, so the first thing is A and not B. It means it's a multiplication between A and not B. So A will be, the values of A will be picked up as it is. But for B, since it is not B, so let me just quickly invert the values of B to make it easier for me. Not B means it's a B bar. B bar means that all of the values of B will be inverted. So whenever if it is 0 for B, we will make it 1. And if it is 1 for B, make it 0. Invert the values and make it B bar so that it will be easier for us to do the multiplication. Now, no need to consider these values. For the first condition, we will be considering this A and we will be considering the values of B bar, and there will be a multiplication. AND means multiplication, a binary multiplication between these two bits. So the first column says that the value of A is 0 and the value of B is 1. 0 into 1 is 0. Write down 0. Then 0 into 1 again, it will be 0. Then 0 into 0 is again 0. Then 0 into 0 is 0. Then 1 into 1 is 1. It means this is the condition when A is 1 and when not B is 1, then your output needs to be 1. Next is this is 1 and this is 1. Again, it will be 1. So this is the condition where your output needs to be 1. Let's see that. 1, 0, multiply 0. 1, 0, multiply 0. So this is how you can calculate A and not B. Now quickly removing all of this to calculate the second condition or to work with the second condition. Okay, the second condition says that your alarm will produce a sound when B and not C is true. So let's see that. B means the values of B will be taken as it is, and it will be AND or multiplied with not C. Not C means that first you have to make C reverse or make all of the values of C inverted. So let's just write down C bar over here. If it is 0, make it 1. If it is 1, make it 0. Just invert the values. Okay. Once you are done with this, now there is no need to consider C. You will be considering the value of B and the value of C bar and multiply them because there is an AND operation between B and C bar or C naught, not C. So look over here in the first column, 0 multiplied by 1 becomes 0. Then 0 into 0 is 0. Then 1 into 1 is 1. This is the condition where the alarm is going to produce sound. 1 into 0 is 0. 0 into 1 is 0. 0 into 0, 0. 1 into 1 is 1. 1 into 0 is again 0. So now the final step would be, according to your logic expression, you have to combine these two conditions through an OR gate. It means that you will be doing an addition. OR means addition of these two values. Whatever the values are, you will be doing an addition, binary addition between them. So let's add all of these to find out the final result. Okay, so the first one, 0 plus 0 is 0. The second thing is 0 plus 0, 0. 0 plus 1, 1. 0 plus 0, 0. 1 plus 0, 1. 1 plus 0, 1. 0 plus 1, 1. 0 plus 0, 0. So that's it. This is the required truth table that you need to produce. Okay, so these are the 4. Look at the output. These are the 4 conditions where your output will be 1. So for these conditions, if you see the values of your inputs, like this is number 1, then you have this, and this. In number 1, value of A is 0, value of B is 1, value of C is 0. So here the output will be 1. Then same goes for when A is 1, B is 0 and C is 0, output is 1. When A is 1, B is 0, C is 1, output is 1. When A is 1, B is 1 and C is 0, the output is 1. So under these 4 conditions, the alarm will produce a sound. Otherwise, it is not going to produce any sound. Not here, not here, not here, and not here. Stay tuned, stay connected, and if you have any queries in understanding this example, comment below so I will answer you. Keep watching. In the next video, I will be coming up with example number 7. Bye-bye.